Hello guys, welcome back to the channel. In our last video on building a Markdown Parser from scratch, I showed you how to build a tokenizer or a lexical analyzer, because that is the job of a tokenizer in our program. It is through this lexical analysis phase that we identify and obtain the valid tokens in our program. Now we are done identifying and obtaining the valid tokens in our program. We need to convert these tokens into an abstract syntax tree, okay, which is short for AST. The AST is produced by the parser. This parser is going to take a flat list of tokens and then it's going to convert it into an AST. The AST is a data structure that can be understood by our compiler. If you missed that video on the tokenizer or the lexical analysis phase, then you can go back and watch it. When you're done watching that video, you can come back onto this one. This parser class is designed to convert a flat list of tokens, which is generated by the tokenizer, into a hierarchical structure called an abstract syntax tree. This AST represents the logical structure of the input, making it easier for subsequent steps like the compiler or interpreter to understand and process the data. This parser will use recursive descendant parsing approach, specifically tailored for a markup language like Markdown. It operates in two main phases. We have block parsing and inline parsing. The parser will have three main methods for now, which is the parse tokens method, the parse block method, and the parse inline method. We will implement the parse tokens and parse block method first, and then I'm going to implement the parse inline method later. The parser will also have other helper methods to simplify the process of parsing. Before we start coding up that parser, let us look at the parsing algorithm. The parse tokens method will receive an array of token objects, which are the output from the lexical analysis phase, just like I said, which is the tokenization phase. Then it is going to initialize or reset its internal state. The internal state is going to comprise of these .tokens, which is going to be a list of tokens to process. We're also going to have another stateful variable, this.current, which is a pointer to the current token being examined, and it's going to start at 0. We are also going to have this.ast, which is the array where the top level AST node will be stored. We are also going to have this.warnings, which collects any issues that arise from as a result of trying to parse the tokens. Next, we are going to enter a while loop that is going to continue to run as long as there are tokens that are left to be processed. Inside this loop, we are going to call this.parse block method to attempt to parse a major structural element from the input. If the parse block method returns a valid AST node, it is going to be added to this.ast array. And finally, it is going to return the complete AST and any one is generated during parsing. So let's dive in. I will create the class parser, and inside it, I will define a tokens variable, which is an array of tokens. For now, it will just be an empty array. Then I will define a current property, which will be a number and it will be equal to 0. Next, I will add an AST property, which is an array of AST nodes. It will store the parsed nodes from the tokens. Then I will define a warnings property, which will be an array of strings. Let's add some helper methods to this parser, starting with the check function. This will take a type property, which will be of token type, and it will return a boolean. I will pause with the function implementation, and then I will define a pick method that returns a token. This function will return the token at the current position of the cursor, which in this instance is the current property. I will define another method on the parser previous, which returns the token before the current position of the cursor. I will also define another method, isAtEnd, which returns a boolean, and this checks if we have consumed all of the tokens simply by checking if the current value is greater than or equal to the length of the tokens array. Next, I will define an advanced function that returns a token. This function will be responsible for moving the cursor. First, we are going to check that we have not gotten to the end of the tokens array, and then we are going to increment the cursor by 1, after which we will return the previous token from the function. Let's head back to the check method, and inside this method, I will return a check that ensures that we have not consumed all tokens from the tokens array, and also that the type of the current token is equal to the type arguments we pass to the function when we call it. Let's add a match method that enables us to match the type of each token and advance the cursor if the type is a valid token. This function will accept an array of token types, and it will return a boolean. Inside this function, I will nest a for loop which iterates over the types array, and for each type, we will check if the type matches the type for the current token, and if it is true, we will advance the cursor and return true, which also ends the loop for us. Now it is time to implement the parse block method. This function will return an array of AST node or node, Inside this function, I will first attempt to pass a heading by checking if there's a match in the tokens array using the match method on the parser. If there's a match with the heading, we will obtain the token by calling this.previous, because the match function advances the cursor by 1, and then we have an object with a type property which will be heading, a level property which will be equal to the token.level property. To obtain the children of this heading node, we have to call the pass in line with the token value to obtain the child. Then we will have to pass a new line. So as long as we match a new line, I will just return null. Let's implement this pass in line method so we can obtain the children of the heading element. This method will accept an input as its argument, and this input is going to be a string. It will return an array of AST nodes. I will declare a tokenizer property on the parser class. We will use this tokenizer to tokenize the input by calling the tokenize inline method. This method tokenizes only inline text that is the child of a node. Remember, I told you that this tokenize inline method will not be called directly. Instead, it's going to be used by the parser class. I will create an array of nodes, which is an array of AST nodes. Then I will create a current variable, which is a number, and it's going to be equal to 0 for now. I will add a while loop that will run as long as we have not consumed all the tokens. And inside this loop, I will obtain the current token and check its type using a switch statement. If the token is a space, then I will push a new node whose type is text and the value will be space. If there's no match, then we push a new warning, unexpected inline token, into the warnings array. If the token is a text, then we push a new node whose type is text and the value will be the token.value. After the switch statement, I will increment current by 1, and after the loop, I will return the nodes array. We need to implement one more method before the parser is complete, and this is the pass tokens method. This method will accept an array of tokens and it will return an object. This AST property will be an array of AST nodes. It will also have a warning property, which is an array of strings. Inside this method, I will set this.tokens to be equal to the tokens argument. This.ast will be equal to an empty array, and this.warnings will also be equal to an empty array. I will add a while loop that will iterate until we have consumed all the tokens from the token array, and I will create a node variable that stores the result of calling the pass block method. Remember, the pass block method will attempt to pass a block level token, and if this token is not null, I will push it inside the AST array. After the while loop, I will return an object with an AST property which is equal to this.ast and a warnings property which is equal to this.warnings. Let's test this parser out by instantiating the parser class. I will call parser.passTokens with the tokens variable, and then I will console log the last variable, which you can observe that we get a nice object with an AST property. If I console log AST0.children, you will observe that this is the children of the first node, and we get an array of nodes where each node is a letter in the corresponding header text. Let's try to pass text strings into a paragraph element. I will navigate to the tokenizer class, specifically the tokenized method, and I will add a new tuple to the block pattern array. This tuple will enable us to identify and pass groups of text. Its type will be text, and it will have a handler function that extracts the match string and sets it as the value of the token. I will scroll down to the parser class, specifically the pass block method, and I will attempt to pass the text token. If there's a match, I will retrieve the token and return a node whose type is paragraph and whose value is the value of the token. The children will be the result of calling the pass inline method with the value of the token as the argument to this method. Remember, this method is going to return an array of AST nodes too. I will test this out, and you observe that we get a new node in the AST array with the type paragraph. Now let's attempt to tokenize and pass links and images. We will do this together since they are very similar in Markdown. I will add two new types to the token type, link and image. You can observe that I already added a paragraph type. I will couple the tuple for links and images, and I will paste it inside the inline patterns array on the tokenize inline method. I will then move on to the parser to attempt to pass these tokens, starting with the pass inline method. I will attempt to match an image, and if there's a match, I will push a new node to the nodes array. The type for the node will be image. The ALT and URL properties will come from the token. Then I will break out of the switch statement. I will also attempt to match a link token, and if there's a match, I will push a new node to the nodes array. Its type will be link. The URL property will also come from the token. It will have a value property which comes from the token, and the children of this node will be the result of calling the pass inline method with the value of the token as the argument to the method. That is, if the link token has a value, otherwise the children will be undefined. Now let's head over to the parseBlock method and I will attempt to match an image. If there's a match and then I will obtain the token, I will return a node whose type is image. The ALT and URL properties will come from the token. I will also attempt to match a link, and if there's a match, I will retrieve the token and return a node whose type is link. The value and URL properties will come from the token. The children will be the result of calling the parseInline method with the value of the token as the argument to the parseInline method. Now let's scroll down to the Markdown string and I'll add a link to the Google homepage, and you can observe that we get a new node in the AST array whose type is link with the URL property that points to the Google homepage and a value property which is the Google placeholder text and a children with 6 extra nodes. I will add a random image to the Markdown text just to see how images are processed. You can observe that we get a new node in the node array whose type is image. It has an ALT property and a URL property. The URL property points to the URL of the image.